Your FastMCP server needs to authenticate clients, but hard-coding provider logic makes deployments rigid and maintenance painful. We'll see how environment-based configuration lets you swap authentication providers without touching your codebase. You'll configure JWT validation and custom providers entirely through environment variables, keeping your server flexible across staging, production, and different identity systems.
#JWT token verification. Export fast server auth equals FastMCP server auth providers JWT verifier. Export fast server auth JWT JWKS URI equals https://auth example com/JWKS. Export fast server auth JWT issuer equals https://auth example com. Export fast server auth JWT audience equals MCP server. #custom provider. Export fast server auth equals my company. Auth custom provider. # plus any environment variables your custom provider expects.
This demonstrates the strategy pattern applied to authentication systems, where different authentication mechanisms can be swapped at runtime without changing the core server implementation. The pattern encapsulates token validation, OAuth flows, and custom authentication logic into interchangeable provider classes, each implementing a common interface. What makes this distinctive is the complete separation between authentication logic and business logic, achieved through dependency injection. The architecture works by delegating authentication responsibility to specialized provider classes that handle protocol-specific details. FastMCP's server core remains protocol-agnostic, while providers manage everything from JWT signature verification to OAuth metadata endpoints. This design enables runtime configuration through environment variables, allowing the same server code to use different authentication backends across development, staging, and production environments without modification. This approach solves the challenge of evolving authentication requirements in distributed systems. It lets you integrate with existing identity infrastructure, JWT issuers, OAuth providers, while maintaining the ability to swap implementations as needs change. The trade-off is that complex providers require more configuration, but the pattern ensures your core application logic remains untouched by authentication changes. This is particularly valuable in microservices architectures, where authentication requirements may differ between services or evolve over time. Let's break it down line by line.
#JWT token verification. Export fast server auth equals FastMCP server auth providers JWT verifier.
This configures FastMCP to use JWT verification for incoming requests. The JWT verifier class handles token validation against your identity provider, ensuring only authenticated requests reach your server. This is the standard pattern for securing FastMCP endpoints with OAuth 2 OIDC.
Export fast server auth JWT JWKS URI equals https://auth example com/JWKS.
This specifies the JWKS endpoint, where FastMCP fetches public keys for JWT validation. The JSON web key set URI enables automatic key rotation without server restarts, ensuring tokens remain verifiable even when signing keys change. Critical for production-grade auth where keys expire or are rotated for security.
Export fast server auth JWT issuer equals https://auth example com.
This sets the JWT issuer claim to validate against, ensuring tokens only come from the trusted authentication server at auth example com. Prevents token spoofing by rejecting any JWT not issued by this exact URI, critical for security in distributed systems.
Export fast server auth JWT audience equals MCP server.
This sets the required JWT audience claim to MCP server, enforcing that only tokens explicitly issued for this service will be accepted. Prevents token reuse attacks by rejecting tokens intended for other services, even if they're otherwise valid. Standard security practice for JWT validation.
Hash custom provider. Export fast server auth equals my company. Auth custom provider.
This overrides the default JWT authentication with a custom provider. You'd implement my company, auth, custom provider, to handle specialized auth logic like legacy systems, custom token formats, or additional validation rules beyond standard JWT. The pattern enables complete control over authentication while maintaining the same FastMCP integration interface.
Hash plus any environment variables your custom provider expects.
This line indicates where you'd add custom environment variables required by your authentication provider. Each provider may need specific configuration, like API keys or service endpoints, to function correctly. Environment-based authentication. FastMCP's JWT verification through environment variables enables 12-factor app compliance, separating configuration from code while maintaining security across deployment stages. The issuer and audience claims must exactly match your authorization server's configuration, including trailing slashes in URIs. This pattern lets the same codebase run securely in development with static tokens and in production with JWT verification.
The environment variable that disappears into the system reappears as the boundary between trusted and untrusted